Hello and welcome sa ating module number 2, second discussion sa Math 104, which is entitled Methods of Proof. So previously, na-discuss natin yung mga principles of logic, especially yung mga rules of inference, kung paano mag-construct ng mga proof gamit yung mga rules of inference o yung mga laws of logic. Okay? So, dito naman sa next discussion natin, titingin tayo ng mga iba't ibang proof techniques. So, meron tayong 5 at nadi-discuss natin ito lahat. Trivial and practice proofs, direct proofs, proof by contraposition, proof by contradiction, and proof by cases. So, recall that a proof is a step-by-step demonstration showing that a given argument is valid. So, gumagamit tayo ng mga logical rules para mag-construct ng mga proof. Okay? So, ang goal natin is maintindihan kung paano ginagamit yung rules at kailan ginagamit. Okay? So, para may reference tayo, i-recall natin yung mga laws of logic or proof techniques na na-encounter natin dun sa last discussion. So, meron tayong double negation or form of an implication, contrapositive, De Morgan's laws, modus ponens, direct proof, proof by contradiction, and proof by cases. So, mostly dito ay na-encounter na natin dun sa last discussion. Okay? So, first is trivial and practice proofs. So, karamihan ng mga results or sa math, mga proof ay ni-state as an implication. So, P implies Q or if P then Q. So, recall natin yung truth table natin ng implication. Ito siya. And let U be a universal set and consider the implication P of X implies Q of X. If it can be shown that Q of X is true for all X regardless of the truth value of P of X, then the proof of P of X implies Q of X is called a trivial proof. So, meron tayong trivial proof pag kaya natin ipakita na yung conclusion natin is true for all X regardless dun sa truth value ng hypothesis natin. So, yan ang trivial proof. So, for example, let X be in R, the set of real numbers. If X is less than 0, then X squared plus 1 is greater than 0. Okay, so yung proof nito, mag-start tayo sa assumption that X be in R. Then note that 1 is greater than 0. Then mag-add tayo ng X squared both sides. So we have X squared plus 1 is greater than X squared plus 0, which is greater than or equal to 0 since si X squared is always non-negative. So, positive or 0 si X squared. So, ito, lagi siyang greater than or equal to 0. So, si X squared plus 1 is greater than 0. Okay? Kasi lagi itong positive. Okay? So, yan. Na-prove na natin yung X squared plus 1 is greater than 0. So, note that hindi natin ginamit yung if statement natin na si X is less than 0. So, naipakita natin dito na regardless nung kung totoo yung if statement natin, yung then statement natin ay always true siya for all X. Okay? Now, kapag may papakita natin na yung P of X, si hypothesis is false for all X regardless of the truth value of Q of X, which is yung hypothesis, yung conclusion, then P of X implies Q of X is true for all values of X. Such a proof is called a vacuous proof. So kung babalikan natin yung truth table natin ng implication, itong last two cases natin yung magbibigay ng vacuously true cases. So pag false yung hypothesis natin, regardless ng truth value ng conclusion ay yung statement natin is true or vacuously true. Okay. For example, let x be in R. If x squared plus 1 is less than 0, then x raised to 5 is greater than or equal to 4. Okay. So note that so x squared plus 1 is greater than x squared, which is always non-negative. Pero since yung hypothesis natin dito, yung if statement natin dito, x squared plus 1 is less than 0, meaning so x squared plus 1 ay negative, ito ay false. Kasi never siyang magne-negative. Okay? So since false yung if statement natin for all x, yung implication natin is vacuously true. So, regardless nung kung totoo man tong x raised to 5 is greater than or equal to 4, naipakita natin na false yung always false yung if statement natin, then meron tayong vacuously true statement. Okay? Yan. So, yan yung trivial and vacuous proof. So, si trivial, pag yung conclusion natin is always true regardless of hypothesis. Si vacuous naman, the hypothesis is false regardless of truth value of conclusion. Okay. Next is direct proof. So yung direct proof, na-discuss na natin to nung last. Mag-start ka sa hypothesis, then mag-arrive ka sa conclusion. Okay? So in a direct proof of P of X implies P of X, we consider an arbitrary element X in the universal set Q for which P of X is true and show that Q of X is true for this element X. Okay. So para ma-illustrate natin to, meron tayong definition. An integer n is said to be an even integer if n equals 2k for some integer k, while an integer m is said to be odd if n equals 2k plus 1 for some integer k. So, definition lang yan. So, sinasabi niya, for example, meron tayong 4. Si 4 ay even integer. So, si 4, pwede natin siyang maisulat sa form na 2 times something, where yung something na yon is an integer. So, si 4 can be written as 2 times 2. Or si 5 is an odd integer, maisusulat natin siya sa 2 times 2 plus 1. Okay? So, even and odd integer. So, meron tayong remark. Every integer is either even or odd but not both. So, wala tayong integer na even siya at the same time odd. Okay? For example, if x is an odd integer, then 5x plus 3 is even. So, since direct proof yung gagawin natin, i-assume natin yung if mag-arrive tayo sa then. So, let x be an odd integer. By definition, since x is odd, then x, this implies, so itong symbol na to, yung sabi niya yung this implies or implication, this implies that x equals 2k plus 1 for some k in z. Okay? So, ang need to show natin, kailangan natin ipakita na si 5x plus 3 is even. That is 5x plus 3 is equal to 2z for some z in z. So, even siya dapat. So, dapat si 5x plus 3, maisulat natin siya sa form ng 2 times some integer. Okay? So, si 5x plus 3, since ang assumption natin, si x ay odd, so si x may susulat natin siya sa form na 2k plus 1 plus 2k plus 1. So, we have 5 times 2k plus 1 plus 3. Then, distribute, so ay magiging 10k plus 5 plus 3, which is 10k plus 8. Then, magpa-factor out tayo ng 2. Okay, so 2 times the quantity 5k plus 4. Si 5k plus 4, si k ay integer, so 5 times an integer, integer times integer is an integer, plus an integer is still an integer. So, i-rewrite natin siya as z, where, so 2z, where z is in z, or set of integers, and z equals 5k plus 4. So, si 5k plus 4 ay integer na. So, therefore, since ito yung need to show natin, na-prove natin yung statement natin. Therefore, 5x plus 3 is even. So, ginagamit natin yung tatlong dots na to, symbolize therefore. Okay. And itong black square is usually end of proof. Okay. Next, another example. If x is an even integer and y is odd, then xy is even. So, assumptions natin dito ay dalawa. X is an even integer and y is odd. Ang need to show natin is yung nasa then, yung xy is even. Okay, sulat natin yung proof. Let x be an even integer. So, anong sinasabi nito? X even integer, this implies that x equals 2k for some k in z. So, definition. Then, yung isang assumption natin, y is odd. So, let y be an odd integer. Since odd siya, we can write it as 2l plus 1 for some l in z. So, gumamit lang tayo ng ibang variable para ma-distinguish natin sila. Need to show xy is even. So, xy is equal to 2 times something or 2z for some z in z. Okay. So, si xy is equal to this since si x equals 2k and y equals 2l plus 1. Then, multiply natin siya. So, magdi-distribute yung 2k kay 2l tsaka kay 1. So, we have 4kl plus 2k. Then, we factor out 2. So, yun yung gusto natin maipakita. We have 2 times the quantity 2kl plus k. So, we can write it as 2z again, where z is in z and z equals 2kl plus k. So, check natin kung integer si z. So, 2 is integer, si k ay integer, so si l ay integer, therefore itong buong to ay integer. Okay. Therefore, xy is even. So, yan yung direct proof. So, direct proof, diretso lang siya. Start ka sa assumptions mo, arrive at the conclusion. Okay. Next, proof by contraposition. So, kung maalala nyo dun sa rules of inference, recall natin, si P implies Q is logically equivalent to not Q implies not P. So, a proof by contraposition is a direct proof of not Q implies not P. So, kung yung direct proof natin na kanina, yung P implies Q, suppose P, then show Q. Ngayon naman, si proof by contraposition, suppose not Q, and show not P. Okay? For example, let X be in Z. If 5X minus 7 is even, then X is odd. So, pwede din natin siyang i-direct proof na ito yung assumption, ito yung conclusion. So, suppose 5x minus 7 is even, then show that x is odd. Pero gagamit tayo ngayon ng contraposition kasi may mga cases na, halimbawa nito, may mga times na mas madaling gawin yung proof kapag yung form niya ay iba, like contraposition. Since logically equivalent naman siya, we can use this kind of proof. So first, sulat natin yung contrapositive niya. So itong si P implies Q, isusulat natin siya as not Q implies P. So, yung if and then magpapalit ng pwesto, then magne-negate yung statements natin. So, X is odd, magiging X is not odd, which is X is even. Then 5X minus 7 is not even, therefore odd siya. So, ito yung contrapositive niya. If X is even, then 5x minus 7 is odd. Okay? So, ito ngayon yung ipiprove natin. So, pag na-prove natin to, para na din natin na-prove yung original statement natin since logically equivalent yung dalawang statements na yun. Okay, so proof. Let x be even. This implies that x equals 2k for some k in z. Need to show that 5x minus 7 is odd. That is 5x minus 7 equals 2l plus 1 for some l in z. Okay. So 5x minus 7 is equal to 5 times 2k minus 7 since x equals 2k. Then multiply. We have 10k minus 7. This is equal to 10k minus 7. Then, maghihiwalay tayo ngayon ng plus 1 or magdadagdag tayo ng plus 1. Kapag nag-plus 1 ako, magma-minus 1 din ako. So, essentially, nagdagdag lang ako ng 0. Okay? So, itong plus 1 minus 1 is 0 lang din siya. So, we can write it as 10k minus 8 plus 1. So, yung minus 1 na isa, pupunta siya, mag-add siya dito. So, we have 10k minus 8 plus 1. Then, dun sa 10k minus 8, magpa-factor out ulit ako ng 2. So, we have 2 times 5k minus 4 plus 1. Then, we have 2l plus 1, where l is 5k minus 4, which is an integer. Therefore, na-prove natin na 5x minus 7 is odd. Okay? So, take note yung step na to. Yung plus 1 minus 1. Pwede nyo din naman diretsuhin na ganyan. Same lang siya. So, para lang alam natin kung paano natin nakuha tong minus 8 plus 1. So, nag-add tayo ng 1, then nag-subtract tayo ng 1, which is basically 0. So, wala lang din siyang effect, kumbaga doon sa statement natin. So, equal pa rin naman yung statements natin. Okay? Another example, let M and N be in R. If m plus n is greater than 50, then m is greater than 25 or n is greater than 25. So proof by contraposition, kailangan natin yung contrapositive niya. So magiging if m is less than 25 and n is less than 25, take note na si not P or Q is logically equivalent to not P and not Q. So ito yung De Morgan's law. So take note niyan na kapag nag-negate ng P or Q, magiging not P and not Q. Ganun din kapag not P and Q, magiging not P or not Q. Okay. So if M is less than or equal, so yung greater than magiging less than or not less than or equal. If M is less than or equal to 25 and N is less than or equal to 25, then M plus N is less than or equal to 50. Ito ngayon yung ipiprove natin. Let M and N be in R and M is less than or equal to 25 and N is less than or equal to 25. Need to show that M plus N is less than or equal to 50. Okay. So first, tingnan natin sila separately. Si M is less than or equal to 25. Tapos si N is less than or equal to 25. So M is less than or equal to 25. Kapag nag-add tayo ng N, magkakaroon tayo ng M plus N is less than or equal to 25 plus N. So we add N both sides. Tapos kay N less than 25 naman, mag-add tayo ng 25 both sides. Okay? Yan. So first, nag-add tayo ng same amount both sides. So true pa rin yung inequality natin. Kung anong ginawa mo sa left side, kailangan mong gawin sa right side. So M plus N is less than or equal to 25 plus N. Then yung N is less than or equal to 25. Mag-add tayo ng 25 both sides. So this implies that N plus 25 is less than or equal to 25 plus 25, which is 50. So meron tayong M plus N less than or equal to 25 plus N and N plus 25 less than or equal to 50. So si 25 plus N at N plus 25 are the same, so commutativity. Therefore, meron tayong transitivity. By transitivity, M plus N is less than or equal to 50, which is what we want to show. Therefore, M plus N is less than or equal to 50. Yan yung proof natin. Yan yung proof by contraposition. So, not Q implies not P. Next is proof by contradiction. So, recall that P implies Q is logically equivalent to P and not Q implies a contradiction. So, yung proof by contradiction, ang flow niya is, i-assume natin si P and not Q, which is yung hypothesis and negation ng conclusion. So kung maalala sa rules of inference, kapag proof by contradiction, nag-start tayo sa negation of conclusion, then mag-a-arrive tayo sa isang contradiction. So assume P and not Q, need to show contradiction, which is a statement that is always false. Okay, example, prove that no odd integer can be expressed as the sum of three even integers. Sulat lang natin siya sa if then form niya. So if n is an odd integer, then n is not equal to x plus y plus z for some even integers x, y, and z. So sinasabi nito na yung odd integer, any odd integer, hindi natin siya maisusulat as sum of three even integers. Okay, so ito yung prove natin. So proof by contradiction, i-assume natin na yung if statement and yung negation ng conclusion natin. So assumption, suppose n is an odd integer, which is yung if statement natin. So n is an odd integer implies that n equals to k plus 1 for some k in z. And negation ng conclusion, negation ng then statement, n is equal to x plus y plus z, where x, y, and z are even integers. So x equals to a, y equals to b, z equals to c. Dahil nga even integers sila. So need to show contradiction. Okay. So we have n is equal to x plus y plus z. Kasi nga, kasama sa assumptions natin. So ang assumptions natin, n is odd and n is equal to x plus y plus z. Yan, n is equal to x plus y plus z, where x, y, and z are even integers. So n equals x plus y plus z by assumption. Then, by assumption then, x plus y plus z, x, y, and z are even integers. So, isusulat natin sila as 2a plus 2b plus 2c. Then, we factor out 2. We have 2 times a plus b plus c, which is 2l for some l in z, where l is equal to a plus b plus c. Since n equals 2l, by definition, n is even. Kasi ang definition ng even integer, masusulat natin siya sa form na 2 times something. Okay? So, this implies that n is even, which is a contradiction to n being odd. Kasi yung assumption natin, n is odd. Therefore, since napakita natin yung contradiction, we can conclude that no odd integer can be expressed as the sum of three even integers. Yung original na statement natin. Another way para masulat yung contradiction, so sa step na to, pwede nyo isulat na this implies that n is even. Since contradiction, ito yung symbol ng contradiction. Contradiction to n being odd. Para hindi nyo na isulat yung mahabang word. Pwede kayong gumamit ng symbol ng contradiction. Pero same lang din siya. Okay? So, ganun yung flow ng proof by contradiction. So, assume P and not Q. Then need to show I contradiction. Another example. If x squared is even, then x is even. So pag proof by contradiction, i-assume natin na x squared is even and x is not even, so x is odd. Assume x squared is even and x is odd. So x is equal to 2k plus 1 by definition of an odd integer. Need to show contradiction. So si x squared is equal to 2k plus 1 quantity squared. Bakit? Kasi si x na ay odd by assumption. Then, expand natin to. We have 4k squared plus 4k plus 1. Then, factor out tayo ng 2 from 4k squared plus 4k. So, we have 2 times 2k squared plus 2k plus 1, which is in the form 2l plus 1 for some l in z, which is equal to 2k plus 2k squared plus 2k. Therefore, si x squared is odd kasi 2l plus 1 siya, which is a contradiction to x squared being even. Contradiction siya sa assumption natin. Therefore, if x squared is even, then x is even. Okay? So, ganyan ang proof by contradiction. Last proof is proof by cases. So, si proof by cases, yung proof natin, di-divide lang natin siya into parts or cases. So, typical cases na nakikita nyo pag integer n. So, halimbawa, if ang opening statement na if n is an integer, so pwedeng n is even or n is odd. So, kailangan nating i-prove yung dalawang cases na yon pag ganun yung case. Next, another case is any real number x. So, real number x, so x, since real number siya can either be three things, so trichotomy. X can be positive, x can be equal to 0, or x is negative. So, tatlong cases. If you have two non-zero real numbers, x and y, case 1, x times y is positive. So, meron tayong subcase. Pwedeng x is positive and y is positive. So, pag multiply natin yun, positive. Or, x is negative and y is negative. So, negative times negative ay positive. And case 2, xy is negative. So, yung subcases niya ay magkaiba ng sign ng x and y. Either x is negative and y is positive, or x is positive and y is negative. Okay? So, kapag magpo-prove tayo ng mga ganitong cases sa real numbers, tsaka integers, usually ipapakita natin siya yung lahat ng cases. So, itong note natin para sa real numbers natin, sa case 2, since yung subcases natin, halos similar lang naman siya, magpapalit lang yung x and y in some cases. So, pwede nating gamitin yung phrase na without loss of generality para i-indicate na yung proof nila ay similar. So, limbawa, nagpo-prove tayo ng something na nandito na case, real numbers, x and y. So, pag x is negative and y is positive, pwedeng similar lang yung case na dito sa pangalawa, nagpalit lang yung variables. So, instead na gagawin pa natin yung proof ng pangalawa, pwede nating i-indicate yung without loss of generality. Okay? May example tayo mamaya nun. So, tingin tayo examples ng proof by cases. If n is an integer, then n squared plus 3n plus 5 is an odd integer. So, proof by cases. Let n be in Z. Need to show n squared plus 3n plus 5 is odd. Okay, so kailangan natin ipakita na n squared plus 3n plus 5 is equal to, let's say, 2k plus 1. It's odd. So case 1, since ang assumption natin n is an integer, n can either be even or odd. First case, suppose n is even. Then n equals 2k for some k in Z. Now, n squared plus 3n plus 5 is equal to 2k quantity squared plus 3 times 2k plus 5 since n is even dito. So, simplify lang natin siya. We get this, which is of the form 2l plus 1. Therefore, for the first case, n squared plus 3n plus 5 is odd. Second case, suppose n is odd, then we have n equals 2j plus 1 for some j in Z. So, same procedure, pero this time, add yung n natin. And simplify lang natin siya. We get this, which is equal to 2l plus 1. Therefore, in any case, n squared plus 3n plus 5 is odd. So, napakita natin na pag even yung n, yung n squared plus 3n plus 5 is odd. And pag add yung n, add pa rin yung n squared plus 3n plus 5. Okay? So, last example, we have real numbers. Suppose x and y are real numbers. Then, the absolute value of xy is equal to the absolute value of x times the absolute value of y. Okay. So, assume that xy in R, x and y are real numbers. Need to show absolute value of xy is equal to absolute value of x times absolute value of y. Okay, first case, tingnan muna natin kung ilang cases. First case is pag positive to. xy is positive. Pag positive yan, we have two subcases. Either they are both, x and y are both positive or they are both negative. Case 2 is xy is negative. Then, subcases natin, x is negative and y is positive, or x is positive and y is negative. Case 3, x times y is 0. So, ang cases niyan, either 0 si x or 0 si y. So, 0 si x or 0 si y. Okay, case 1. Case 1.1. So, we have 1, 2, 3, 4, 5, 6 na subcases na ipoprove natin. Case 1.1 is x and y are both positive. Kapag positive sila, walang problema since absolute value ng positive numbers ay positive. By definition ng absolute value, recall na ang absolute value of x is equal to x if x is positive, so 0, and negative x if x is negative. Okay? So, definition ng absolute value. So, yung case 1, ganyan lang siya. Case 1.1. Case 1.2, they are both negative. So, absolute value ni xy is, since x is negative and y is negative, masusulat natin siya sa form na negative x times negative y. So, this is xy, which is equal to negative x times negative y, which is equal to absolute value of x times absolute value of y. So, pwede natin ilagyan na absolute value bars. Next case, case 2 is xy is negative. So, without loss of generality, let x be negative and y be positive. So, sinasabi natin dito na yung case nung x positive and y negative, similar lang yung proof niya. Okay? So, absolute value of xy, since case 2, xy is negative, so by definition ng absolute value, ito ay negative time negative quantity of xy, which is equal to negative x times negative y, which is equal to absolute value of x times absolute value of y. Okay, so yun yung case 2. So instead na ipo-prove natin yung 2.1 tsaka 2.2, isang proof na lang siya. Kasi pag yung isa, magpapalit lang yung pwesto ng variables. Pero same lang din yung proof niya. Case 3.1, x is 0. If x is 0, then we have yung absolute value of xy is absolute value of 0 times y, which is absolute value of 0 is 0. Yung absolute value of x times absolute value of y is 0 times absolute value of y, which is also 0. Therefore, by transitivity, we have yung absolute value of y is equal to 0, which is equal to absolute value of x, absolute value of y. Therefore, by transitivity, the absolute value of xy is equal to absolute value of x times absolute value of y. Okay? And case 3.2, same procedure. This time y equals 0. The same steps. Dito naman, si y yung 0. So, the absolute value of xy is the absolute value of x times absolute value of y. Therefore, sa lahat ng cases, in any case, absolute value of xy is equal to absolute value of x times absolute value of y. Okay? Yan. So, yan yung methods of proof techniques natin. So, again, meron tayong trivial and vacuous proofs. So, si trivial proof, pag true yung conclusion natin regardless ng hypothesis, so trivial siya. Vacuous proof naman, kapag false yung hypothesis for all x regardless ng conclusion. So, direct proof, assume P, show Q. Si proof by contraposition, assume not Q, show not P. Si proof by contradiction, assume P and not Q need to show contradiction. And proof by cases, nadi-divide lang yung proof into parts or into cases or sub-cases. Depende doon sa given hypothesis natin. Okay? So again, kung meron kayong questions sa discussion sa module or sa exercises, i-PM nyo lang ako or contact nyo lang ako. At so yung coverage ng prelim exam niyo is the first two modules. So yung principles of logic tapos itong methods of proof. Okay, so good luck sa pagsagot, galingan sa pagsagot, and see you next time. Bye!